So last week we finished until this part. Okay. We have two kind of sequence-based priority queue. So the first priority queue means we want to implement with an unsorted list. So every data that we insert, it will be inserted at the beginning or at the end, okay, at the end, at the end, at the end. And then after we want to remove the minimum, we will sort. The sorting will happen later. So sometimes we can mention like this one as the insert first, sort later. So we insert all the data first, and then after we want to remove the data, we sort it. Second one, so we want to sort first and insert later. So we want to check where is the position of one. Okay, if one is the smallest value, so I want to put in the first part of the sequence. Then I will sort this on the key, and then I will insert this on the position of the key. So that's why we call it this is implementation with the sorted list. So the code will be something like this one. We have the unsorted priority queue, and we are using the priority queue base. Okay, so the priority queue base I mentioned to you before about this one. This is the superclass. So we want to find the minimum. So finding the minimum means first we will check whether it is empty or not. If it is empty, then priority queue is empty. If it is not empty, then we will check the first, and then we will check what is after the first. So we will do the loop. We will do the loop while what is not known. So whenever we still have the data, so we will check whether the element is the smaller than the first element. If it is smaller, the walk element is smaller than the small element, then let's change the small into the walk. And then walk equals to the data after walk, and we will return the smallest data. This is the constructor, this is the length, and this is to add a new data. This is the minimum, and this is to remove minimum. Sorted priority queue. So we want to sort. We want to sort first and insert later. It also use the priority queue base. So we will construct, okay, construct the object, and we are using the positional list. So we've also learned last time about the positional list, and we want to check the length of the data. And whenever we add a new data, so we will make a new object, which is newest or the new instance. And then what it will be the list data, and check if what is not known and the newest is less than the what the element. If both of them are true, so we will determine walk equals to the self dot data before the walk. If the walk is not known, then put the data into the first. If the walk is not known, then put the data after the one. So we can have the minimum means I want to check what is the minimum data from the list. So if it is empty, just erase the empty. If it is not empty, then we will check what is the first data. Remove min means I want to check what is the first data and then remove from the list. So the priority queue sorting. The priority queue sorting means we can use a priority queue to sort. Sort means I want to arrange from the maybe from the small to large value because this is ascending. Or we have the sorting with descending. If it is descending, it is from large value to small value. So we insert the elements one by a series of add operation. So we have add operation and then remove the elements in sorted order with a series of remove min operation. So the operation will be add, remove min, add, remove min. So the running time of this sorting method depends on the priority queue implementation. So you need to know how to implement this priority queue. For example, yeah, if we use the priority queue sort, we have a sequence S and we have comparator C. So the output will be a sequence S sorted in increasing order according to C. So P is the priority queue with comparator C, while not S is empty. So while S is not empty, while the sequence is not empty, remove from S and put it into the object E. And then we will put into the P. P is the priority queue. P is the priority queue. So we put the E into the P until this one empty, until the sequence empty. And then we will check the P. If P is not empty, then remove min dot P. So we will remove the minimum value from D and put it into the object E. Then we will put the E at the last of the sequence. So the strategy for the sort, we have selection sort. Selection sort is the variation of PQ sort. So PQ sort is this one, PQ sort. This is the parity Q sorting. Selection sort is the variation of PQ sort where the parity queue is implemented with an unsorted sequence. Unsorted sequence means you put the data maybe at the last of the list, 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 and then after you want to remove it, you will remove it according to the smallest key. So it means we will insert first and sort later. So the running time for the selection sort, inserting the elements into priority queue with n insert operation will take O(n) time. So if you put every element, this one, into the priority queue, and if there are n elements, it will take O(n) time. Removing the elements in sorted order from the priority queue with n remove min operations takes time proportional to 1 plus 2 plus blah 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 until n. So with this one, we have O(n). With this one, we have also O(n). So the selection sort, it will run on power of 2. Now let's see with this example. Okay. So I have a sequence. So the sequence is 7, 4, 8, 2, 5, 3, 9. So it means if I have a new element 7, okay, and then a new element 4, so I put after 7. A new element 8, I put after 4. A new element 2, a new element 5, a new element 3, a new element 9. So this will be the sequence. I'm going to use the priority queue. This is another storage, or we call it, yeah, this is another place to store the data. And the first phase, or the phase one, we will remove from S and put it into P. So we will remove 7. So we will remove 7, and then we will remove 4. We will remove 8. We will remove 2. We will remove 5. We will remove 3. We remove 9. So in the priority queue, we will have the same sequence like this one. And after we have this priority queue, we go into the phase 2. So the phase 2, because we already have this sequence in the priority queue, so when we want to put into the sequence back, we want to put into this S. So we will check among this one, which is the smallest. Okay, we know that the smallest is 2. So we remove the min. We remove the min and put here. And then we have another minimum. We put after 2. And then we have another minimum. This is what we put after 3. And then we have minimum 5. We put after 4. We have another minimum 7. We put after 7. And so on. So the process of sorting happens after I remove every of the sequence into the priority queue. So we do the sorting and then we place back to the sequence. So the sequence, or the final sequence, will be the sorted list. So the sorted list will be from the small value, which is 2, and 3, 4, 5, 7, 8, 9. There's another kind of sort. We call it insertion sort. With the insertion sort, it is the variation of PQ sort. This is the priority queue sort, where the priority queue is implemented with a sorted sequence. So the sorted sequence means we will sort first, and then insert later. Now, the running time of the insertion sort, the first we will insert the elements into priority queue with an insert operation. So the n insert operation will have like 1 until n. So it means ON. And removing the elements into sorted order from the priority queue with a series of n remove min operation, it will take ON. So the insertion sort runs in ON of 2. So if we look at this example, we have the data again. So this is the data that we have 7, 4, 8, 2, 5, 3, 9. And then we want to do sorting. So the sorting happens if we select from the beginning. Okay, we put 7. And then we choose 4. So 4 will be checked with 7. 4 and 7. Which one is smaller? I know that 4 is smaller than 7. Then the sequence will be like this. Next will be 8. So 8 will be compared with 4. Okay, 8 is higher than 4. Then it will check with 7. Okay, 8 and 7. So 8 is higher than 7. So we will put 8. Next is 2. So 2 is smaller than 4. Okay, then we put 2 before 4. So the sequence will be like this. So 5, I will check with 2. Okay, 5 is higher than 2. And it goes next. 5 and 4. So 5 is higher than 4. Then I will check next. 5 is lower than 7. And it will be in this place. Then we have 2, 4, 5, 7, 8. We go to 3. So 3 compared with 2. 3 is higher than 2. And then go to 4. 3 is less than 4. Then we will have 2 and then 3 and then 4, 5, 7, 8. And then the last we will check 9. So 9 is the value higher than 2, higher than 3, higher than 4, higher than 5, higher than 7, higher than 8. Then we put 9 here. After we have the sequence in the priority queue with the sorted order, so we can just remove the minimum. We remove the minimum to the phase number 2. Remove the minimum, 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 and remove the minimum. So the operation of this one, yeah, it is still the same with n of 3. We have another kind of sorting, we call it in-place insertion sort. If it is in-place insertion sort, it means we do not use any external data structure. So when we use the sorting, we use the PQ sort. So we assume that we have P. P is the priority queue data structure. So instead of using the external data structure, so I do not want to use P, we can implement selection sort and insertion sort in place. So I have the list like this one, 5, 4, 2, 3, 1. So a portion of this input sequence itself serves as the priority queue. So we can say this is also a priority queue, or this is a data structure of priority queue. So for in-place insertion sort, we keep sorted the initial portion of the sequence. And we can use swap instead of modifying the sequence. So swap, if you still remember when we do with the array, swap means we want to remove the position. So this algorithm, if we have 5, 4, 2, 3, 1, then we will check one by one, similar with the previous one. So 5, I want to check with 4. 5 and 4. If I want to make ascending, ascending means it is sorted from the smaller value until the higher value. Then I will check 5 and 4. 5 is smaller than 4? Yes, because, well, so 5 is higher than 4, so we swap. Because 5 is higher than 4, so we swap. 4 and then 5. So 5, we will check again with the next number. 5 and 2 is 5 higher than 2? Yes. So swap. After we swap with 5 and then again check 2 and 4. So 2 and 4, because 2 is smaller than 4, then we put 2 here and then 4 and then 5. After that, we will check again 5 and 3. 5 and 3, we know 5 is higher than 3. So we swap. 3 and then check with 4. 3 is smaller than 4. So we swap. And then check 3 and 2. Because 3 is higher than 2, then just skip the position like that. 2, 3, 4, and 5. And then check 5 and 1. So 1 is smaller than 5. So we swap. So 1 is smaller than 4. Then swap. 1 is smaller than 3. Then swap. 1 is smaller than 2. Then swap. So the final result will be 1, 2, 3, 4, 5, like this one. Okay, so that's the insertion sort. Now let's move to the second one. We call it merge sort. So some of your team project, you want to use the sorting. So this can be helpful for you to do the team project. Merge sort, it is based on the divide and conquer strategy. So we will learn about the merge sort and what is the analysis of the merge sort. The merge sort, it is based on the divide and conquer. Divide and conquer is a general algorithm design paradigm. Divide means I'm going to divide the input data S into two disjoint subset. Two disjoint subset. So if I have a subset, so I will split into two. And the two will be different in the data. So we have S1 and S2. We have S1 and S2. It means we solve the sub-problems associated with S1 and S2. Conquer means combine the solution for S1 and S2 into a solution for S. Because it is a kind of recursion, we call it recur. So we need to define the base case. So the base case for the recursion are sub-problems of size 0 or 1. So merge sort is a sorting algorithm based on the divide and conquer paradigm. So the notation, the people notation, it will be like heap sort. So I do not explain the heap sort, but in the heap sort, it will have n block n one line. So why it is log n log n, I will explain to you later. But this is different with heap sort. In the heap sort, they try to use the auxiliary priority queue. So we learned the PQ sort. So it used the priority queue. So there is another way to use heap sort, but I do not explain this one. So the merge sort, it is only based in the sequential manner. So it access the data step by step. So it is suitable to sort data on a disk. Okay, so the algorithm of merge sort actually it has three steps. Merge sort on an input sequence S with n element consists of three steps. The first we will define. So partition the S into two sequences S1 and S2 where the element or the number of elements about n divided by 2. And then do the recursion for S1 and S2 and concur. So it merges S1 and S2 into a unique sorted sequence. The algorithm is like this one. We want to do merge sort S. To input the sequence S with the n elements, the output will be sequence S sorted according to C. And then if the size is higher than 1, partition into 2. And then we will do merge sort S1, we will do the merge sort S2, and then at the end we will do G. So there is also another algorithm how to merge. Merging the two sequence means if I have A and B, so the input is A and B with n divided by two elements. So the output will be A union B. So it will be the combine of A and B. It will start from S, which is empty sequence. So if A is not empty and B is not empty, so check what is the first element in the A and check what is the first element on B. If the A first element is lower than B first element, then put the A, remove the A first, and then put into the S. If you have B as the smaller element, then you put the first of B into the S. So if A is not empty, then remove the first. If B is not empty, then remove. So this case happen when there is this one, when there is no data on B, and this happen when there is no data on A. So the control step of merge sort consists of merging two sorted sequences A and B into sorted sequence S containing the union of elements A and B. Merging two sorted sequence, it's with n divided by two element and implemented by means of the doubly linked list, it takes O n time. Okay, so if you still remember doubly linked list, we can implement into the merge sort. So this is the code, the Python code. If you use the sorting algorithm for your project, you can use this one. So the merge S1, S2, and we want to merge it into S. So if the length, if J equals to the length, and I is less than length, and Sij is less than S2J. So we will check Si plus J equals to S1I. So we want to copy the I element into S1 as the next item of S, or we want to copy the J element of S2 as the next item of S. So this while will complete all S1 and S2 into the S, into the S. Actually, this merge sort is similar with the binary sort. When you have the binary sort, you will also divide into mid value. So we use the mid value, and then after we have the mid value, we will sort, and then we will do the merging. Okay, I think I will stop here. I will explain the merge sort tree on Wednesday. Okay, thank you very much for attending. We will meet again on Wednesday. Terus sudah